Hello everyone, welcome back to our YouTube channel. Myself, I am 𝗟𝗲𝗃𝗲 Reddy, working as a software developer and instructor at Smart Interviews. In this video, we are diving into the latest Codechef contest, that is Starters 215. If you did not subscribe to our YouTube channel yet, do it right away. And wasting no time, let's jump into the first question. You are participating in an elite chess tournament for 4 people in the world only. There are prizes in this tournament, obviously. If you finish rank I, you get 1000 into 2 power 4 minus I rupees. Thus the prices are as follows. Okay, if I'm at rank 1, I'll get 1000 into 2 power 4 minus 1. Okay, so I'll get 1000 into 2 cube is 8, so 8000. Okay, similarly 4000, 2000, 1000 for ranks 2, 3 and 4. Okay, we finished at rank X. How much prize money did you win? Okay, that is straightforward. All you have to do is you just have to read an integer and print this value 1000 into 2 power 4 minus second. Okay, pause the screen and quickly complete that code and then come to this video. Okay. Okay, as we have seen, in the input will be given an integer x. Okay, we'll write the same. We'll read an integer x from the input. You can just write 4 conditions. If x is 1, print this, print that value. If x is 2, print some value. If x is 3, print this. If x is 4, print. Ideally, we can write these 4 conditions as the value of x is just 4. Instead, we can directly write that mathematical equation that we are having here. Okay, so how many coins will he, how many rupees will he get? As mentioned, 1000 into 2 power 4 minus I, right? So power of 2 comma 4 minus x. Okay, this is basically 2 power 4 minus x, right? So okay, this is ideally 2 power 4 minus x. What we can simply write is 1 left shift 4 minus x, both are same, and we'll print these rupees. That's it. Run the code. Okay, we'll submit it. Okay, so that is with the first question. We'll move on to the next one. Just gem bundles. You have given R red gems, B blue gems, and G green gems. Each gem normally sells for 3 coins. However, if you make a bundle of 1 red gem, 1 blue gem, and 1 green gem, you can sell it for 10 coins instead. What is the maximum number of coins you can earn? Okay. Okay. We'll try to understand the sample input and output. If I'm having 1 red, 1 green, and 1 blue, one way is to sell each of these things individually. So 3 coins plus 3 coins plus 3 coins, which will give us 9 coins. There is an alternative way as well, where you can pick 1 from here, 1 from here, 1 from here. And if you sell this triplet at a time, the triplet value will be 10. As you can form one triplet can give you 10 rupees, which sells for 10 coins. Okay, so 10 coins. Obviously we wanted to maximize the number of coins as per the problem statement, so you'll consider this and you'll return 10 as the answer. Okay, we'll see the next test case. 0, 10, 10. So here if you see, ideally if you see here, obviously we should always prioritize picking a triplet first. Okay, if you see here, there is no way of going ahead with a triplet. You should only go with the first way, where sell these coins for each for 3 coins, thus each for 3 coins. So overall there are a total of 20 coins. 20 into 3 will give you 60. That is what we got here as well. Okay, next is 5 to 4. So what should we do now? What will be the optimal way of maximizing the number of coins? As simple as you can pick one triplet, uh, which will become 4, 1, 3. You can again pick a triplet and you'll get 3, 0, 2. And from here, okay, so far, how much you got to earn? 10 from here to here, 10 from here to here. Next, you should just sell these things individually. That's it. These 3 coins into 3, which will give you 9. These 2 gems into 3, which will give you 6. 9 plus 6 is 15. And 15 plus 20 gives you 35, which is the expected answer for third one. That's what you're supposed to do. Okay, I hope the question and the explanation is clear to you. If yes, you can just pause the video and you can implement it. Okay, if not, you can just reiterate on this explanation and all. Okay, we'll implement this now. As per the problem statement, you'll be given now t number of test cases first. So we'll just look for that for underscoring range int of input. What will I do? I'll read R, G, B. All these 3 values I'm reading. Input dot split. Okay. Now, as mentioned earlier, I'll first try to form the triplets. So how many triplets I can form overall? Let's say some x number of triplets. And this x is nothing but minimum of R comma G comma B. That's it. How many coins are left out? How many coins are left out? As simple as total number of red gems plus total number of green gems plus total number of blue gems minus 3 into x number of 3 into number of triplets that we can form. Okay, and for the first x number of triplets, we can get into 10 coins, and for the remaining number of gems we can sell it for 3 coins. So overall x into 10, which means the number of triplets into 10 plus remaining gems into 3. Okay, we'll run the code. Okay, we'll submit it. That's it. We'll move on to the next question. Question special missions. You're playing a game with n missions to complete. Okay, I have to complete n missions. The ith mission pays AI coins. You can choose whether to complete each mission or not, and also the order in which way you want to complete them. Okay, however, okay, there are n missions, and ith mission faces AI coins. Okay, fine. However, some of the missions are not special ones. And to access them, you need to pay a one-time fee to a wizard of C coins. Okay, we have to just pay it once to a wizard. Okay, what is the maximum number of coins you can update? You start with 0 coins. Note that you cannot have a negative coin balance at any point of time. That is, if you decide to pay C coins to the wizard to unlock the special missions, you must have at least C coins with you beforehand. Okay, got it. Got it. Let's just try to understand the input format. First line will be given T number of test cases. Next, in each test case, I'll be given N and C, where C is the number of coins that we're supposed to give to this wizard. Okay. Second line contains the array elements. Third line contains a binary string S. Okay, let's say something like 0, 0, 1, 5. Okay. Now, what is this binary string significance? Okay, you are given a binary string S, where if S of I is 1, okay, where S of I is 1 if the ith mission is special, and S of I is 0 if it is not special. Okay, got it. Hmm. Fine. Let's try to understand each and every test case. So I'm given 2 missions to complete, and the special price that I need to give to a wizard is 2. And this 1,5 represents the number of coins that I get on completing 0th mission. 5 number of coins that I'll get if I complete first mission, index 0 based first mission. Okay, and it says A of 0 is not special, but A of 1 is special. Okay, so what will I have now? Obviously, as it is not a special mission, I can complete it without any interruptions. Okay, as of now, 1 plus. Now I'm having 1 coin on my hand, and to complete this task, it is a special mission. To complete the special mission, I want to approach a wizard, and this wizard will ask for C number of coins, but I'm having a single coin, so I cannot complete this task. And so the answer for the first test case would be 1. Okay, that's what we got here as well. Fine, we'll move on to the next test case, which says that we are having 2 missions to complete, and wizard 2, and again here 1, 5, 1, 0 this time again. So what do you see now? To even complete special missions, prior to this, uh, in the problem statement, we are also given that you can complete that missions in any order you want. So as simple as that, I can just complete all the non-special missions first. So okay, I'll complete this. Now at this moment in my hand, I'm having 5 coins plus. Now I'll give 2 coins to the wizard. 2 coins to the wizard. So he can now complete any number of special tasks, special missions that he is having. Okay, doesn't matter. Let's say 100 uh, missions is having, 100 special missions we are having. You just have to make a one-time fee to a wizard. You should pay a one-time fee to a wizard. Okay, fine. Let's consider the same example itself. Okay, 1. If I spend 2 coins, if I spend 2 coins, I'll get 1 coin. Okay. I'll get 1 coin. So 5 minus 2 plus 1 is 4. But instead, if I completely skip doing this mission itself, if I skip spending 2 coins to the wizard, I'll not get this. In that case, what will be the answer? 5. So I wanted the maximum number of coins at the end. So this wouldn't be the answer. 5 will be the answer. That's what I got here. Fine, let's move on to the next test case. It says I'm having 4 missions to complete and uh, I have to spend 5 coins to complete any special mission for the first time. Next I'm having 10, 10, 10, 10. 0, not a special mission, not a special mission, special mission, special mission. Fine. Now what's the next step? What's the next step now? As mentioned earlier, I'll first complete all the non-special missions. So I can complete this, I can complete this, which gives us 20 coins. Plus, plus, uh, what will I try to do? If you see here, if I'm having maybe 1 and 1, what will I have the answer as? 20 itself. Why would I spend 5 coins to a wizard and get 2 coins in return? I wouldn't do that. Only if the return value is greater than 5, then I can maximize the number of coins, right? But yeah, this is one intuition that you need to understand. As I'm having 10 and 10, at this moment I'm having 20 coins. If I spend 5 coins on wizard, he can now help me get these missions. One payment to a wizard can help you make this 0, 0. Doing that one time fee payment is enough so that he can help you convert all these ones to zeros. Okay, now I can do this and this. So plus 20. So 40 minus 5, 35, which is the answer for next test case. Okay, next I'm having 2 missions to complete and I have to spend 1 coin on a visit. So 100, 100, 1. This is a special mission. This is a special mission. As I'm starting with 0 number of coins in the initial stage and I'm having no special missions in this example, I cannot even complete a single task. So it will remain 0. Yes, that's what we are having. Next, the final test case. We are having 3 missions to complete and I have to spend 6 coins on a visit. So this is not a special mission. This is not a special mission, and this is a special mission. So what will I do now? What will I do now? As simple as I'll first complete all non-special missions, which will give us 6 coins. And now I have to spend 6 coins on a wizard to make all the special missions to non-special missions. Okay, I'll spend and check. Okay, at this moment I'm having max possible answer as 6. Okay, I'll spend. And now I'm able to convert all special missions to non-special missions. And now it became non-special and I'll now perform that. So this is nothing but 100, which is a new better answer than the previous existing maximum, which was 6. So this will be my new answer. And yeah, that's what we got. Okay, so this is all about the problem statement. It is an interesting one. Pause the screen. See how we can implement this. Work out, put your thoughts on a paper and implement this. If you're not able to get that, that's fine. We'll discuss the logic and we'll start writing the code. Okay. So coming to the logic, as we did it here, we'll just do this. If not a special mission, what I'll try to do is maybe I'll just say current number of coins equal to array of I. Else, else that must be a special mission, right? So let's say special mission coins plus equal to array of I. Okay. We'll consider this example. We'll consider this example and we'll validate this. Okay. Now, I'm having at this moment my current is holding 20. My special is also holding 20. Okay. Now, I'll try to pick and I'll try not to pick as well. Okay. Answer equal to 20 at this moment before considering any, before involving the wizard. Okay, now I'll try to involve the wizard. First of all, can I blindly involve the wizard? No. It is because at any instance, I can never have a negative coin balance. Okay, I can never have a negative coin balance. As in, if current is greater than or equal to the amount that you want to spend on a wizard, only then you can consider only then you can consider the special missions. In that case, answer will be max of answer common answer common the current number of coins plus special missions minus. Okay, first you'll spend those many coins on visit, so minus C, plus once you spend C number of coins on a visit, he can give you all special mission coins. That's it. We'll implement the same in the code. Okay, we'll now implement it. Let's see the input format. Okay, first we'll have two test cases. Okay, now we need to read n comma c. Next I'll have this array. Okay, next line I'll be having a binary string. Okay. Now at this moment, what we'll do, we'll iterate over the non-special missions and we'll just sum up to some current variable. And also, if a mission is special mission, we'll add it to some special variable. Okay. Now I'll just iterate for I in range of n. If s of I is 0, if it is not a special mission, I can simply complete that mission, which will give me these many number of coins. Else special plus equal to array of I. Now I'll first consider the answer uh, where I'm not picking the special missions at all. Okay, I'm not. This is the answer before involving the wizard. Now, if I want the wizard, if I want to involve the wizard, the first thing that I need to check is whether my current uh, number of coins which I'm having before involving the wizard, if it is at least greater than or equal to number of coins that I'm having. If that is the case, I'll include the wizard. So curve minus C number of coins I need to involve plus the special mission coins that I'll get. And here I'll just put in the answer. That's it. Run the code. Okay, we'll submit it. Okay, in fact, we'll move on to the next question. So we are given a binary string s of size and parameter k. We are wondering whether it is possible to rearrange the characters in S such that the following condition is satisfied, where S of I is not equal to S of I plus k. Okay. Print yes if it is possible to rearrange S in such way, and no otherwise. Okay. Fine. We'll see this. First test case 4, 1, where n represents the size of string and k represents this condition where S of I not equal to S of I plus k. For any instance of I, this condition should be satisfied. Okay. For any instance of I, S of I should never be equal to S of I plus k. Okay. We should somehow handle this. Okay, fine. I'm having 1, 0, 1, 0. Okay. When I is at 0, okay, we'll just check. If I is 0, S of 0 shouldn't be equal to S of 0 plus 1. And also S of 1 shouldn't be same as S of 2. And S of 2 shouldn't be same as S of 3. That's it. Now, I'm having the current string as 1, 0, 1, 0. This is index 0, this is index 1, this is index 2, and this is index 3. Okay, now if I see S of 0 is not same as S of 1, and S of 1 is not same as S of 2, and S of 2 is not same as S of 3. So it is already being you're already given such a valid string. So you got the answer as yes. Okay, this is fine. We will move on to the next test case. It says 4, 3, 1, 0, 0, 1. Okay. As the value of k is 3 here, as the value of k here is 3, what do you have to check now? S of 0 shouldn't be same as S of 3. And everywhere else you can have it. S of 1 can be equal, cannot be equal, doesn't matter. Okay, it doesn't matter if it is equal to or not equal to S of 2, it is still a valid part. Okay, and S of 1 can also be equal to S of 3, and S of 2 can also be equal to S of 3. Doesn't matter, right? It doesn't really matter. The only thing is, okay, we are having some 4-length string. Only these two shouldn't be same. Okay, only these two shouldn't be same. Okay, at this moment, we are having number of zeros 2, number of ones we are having 2. Okay, 2 and 2. Okay, now let's just place 1, 0 here, 1 and 0 here. Okay, in that case, okay, this is being satisfied. And what about anything remaining? This can be equal or not equal to, doesn't matter. Equal to or not equal to, doesn't matter. So maybe we'll place 0, 0. But are we having 3 zeros? No, we are only having two zeros and two ones. Okay, maybe we can place something like this. We can rearrange it and place something like this. That's it. Okay, which is now satisfying. Okay, we'll consider it for the next test case. We'll consider it for the next test case as well. Mm, okay, 4, 1, 1, 1, 1, 1. Okay, and in this case, S of 0 shouldn't be same as S of 1. S of 1 shouldn't be same as S of 2. S of 2 shouldn't be same as S of 3, no matter what. Okay, and here if you see, I'm having all ones. Okay, number of zeros, I'm just having 0, and number of ones, I'm having 4. Number of ones, I'm having 4. What do you mean by that? What do you mean by that? Is there any instance where I can have S of 0 not equal to S of 1? No, I cannot have. So obviously the answer for this will be hmm, will be no, no. Okay, we'll see it for the last one, last test case as well, which is 4, 2. Okay, and 111, 0. Okay, what I should do now? What I should do now? Okay, I'll just keep a track here. Zeros now. I'm having the number of zeros, 1, and the number of ones I'm having at this moment, 3. Okay, and overall, S of 0 shouldn't be same as S of 0 plus k, right? S of 2. And S of 1 shouldn't be same as S of 3. So let's just consider a 4-length string. Okay, remember, this is the condition, right? S of I should never be same as S of I plus k, as per the question. Okay, we'll also write down the indices 0, 1, 2, 3. And now, and now, um, I shouldn't have S of 0 same as S of 2. I can either place 0, 1 or 1, 0. Okay, let's just go ahead with 1, 0. And S of 1 shouldn't be same as S of 3. Okay, S of 1 shouldn't be same as S of 3. Okay, either you can place 1, 0 or 0, 1. Now this is one valid thing. Or you can even have 1, 0, 0, 1. Even this is valid. Okay, and also you can even have 0, 1, 0, 1. I mean this is valid. Okay, is this valid? No, this is not valid. Okay, this is valid. Okay, this is valid. And it is obvious that when you have a single zero present in the given string, it is not possible to form. Uh, I mean, it is not possible to rearrange the given string and satisfy this condition. It's not possible. So we'll return no at the end. Okay, so how do we solve this problem then? How do we solve this problem? Let's just consider, uh, for an instance, let's say maybe the value of n is 10 and k is 4. Okay, so what do you see here? S of 0 shouldn't be same as S of 4, and S of 1 shouldn't be same as S of 5. S of 2 shouldn't be same as S of 6. S of 3, S of 7. S of 4, S of 8. S of 5, S of 9. Okay, so we'll just consider a 10 length binary string. We'll also write down the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we are having this. Fine. Now we'll consider it on this basis. So 0 shouldn't be same as 4, and 4 shouldn't be same as 8. As in what do you mean by that? You can either place 0, 1, 0 at these slots, or 1, 0, 1 at these slots. Okay, let's go ahead with 0, 1, 0. Fine. Let's place 0, 1, 0 here. Now that is all about index 0. Now we'll go to index 1. And when it comes to index 1, 1 shouldn't be same as 5, and 5 shouldn't be same as 9. What do you mean by that again? You can either place here as well, you can either place 0, 1, 0, or 1, 0, 1. You can choose either of these things. Let us go ahead with maybe 1, 0, 1. The reason is let's say uh, okay, let's discuss both of these scenarios. Let's say we are having the count of zeros being very less. In that case, what you should ideally plan to do here, you should maybe plan to have 1, 0, 1 here instead of having 0, 1, 0. Right? Okay. In the same way, you're able to cover all these 6 indices just by two zeros. Just by two zeros. Okay. We'll move forward. We'll see. And 2 shouldn't be same as 6. And 6 shouldn't be same as 10. But ideally 10 is out of this range. So yeah, you can consider 2, 6. And you can either place 1, 0 or 0, 1. Let's say 1, 0. So till now you have used 3 zeros. Next, S of 3 shouldn't be same as S of 7. Okay, let's place 1, 0. Okay, let's place 1, 0. So you had 4 zeros. So the problem statement is, if you are having at least 4 zeros in your given string, you can place this for this approach. Okay, in the same way, ultimately what I need to do when you're at 0, what all kind of windows do you have? It is 0, 4 and 4, 8. This 3 you need to consider. And similarly 1, 5, 5, 9. And next 2, 6. And next 3, 7. And next 4, 8. This is how you need to consider these values. Okay, and yeah, that this 48 is already covered, and yeah, this 37. That is how you need to form this. And it is actually fine if you are having more than 4 zeros in your given string, because what's the thing here? Instead of placing 101, you go and place 010. That's it. So ideally, the number of zeros that you get for this particular, I mean 010 or 101. This way, if you keep on building, the minimum number of zeros should definitely be. I mean, if you keep on placing 010, uh, this ideally the whole number of zeros should definitely be lesser than or equal to number of zeros present in the array. And if you went on placing 101s, this must be greater than or equal to number of zeros present in the array. So this is when we consider placing zeros. This is when we are considering prioritizing zeros. And if you kept on placing zeros, you must have at least, I mean, you must have at max each number of zeros in S. So that is the whole point here. And similarly, 101, if you wanted to place 101, and here if you see, you are minimizing the number of zeros, and this must be greater than or equal to number of zeros that you are having in the given string. That's it. If you can do this, and similarly for 1 zeros or 0 1s, it's the same point ultimately. Okay, I hope the logic is clear for you. If it is clear, you can just stop the screen, and you can implement this question. And once that is done, you can come back to the video and we can continue. Okay, we'll code this up. As per the input format, we'll be having the t test cases, and then we have to read n comma k. And now we have to read a string. Okay, so as we discussed, we need to count the number of zeros, or alternatively, we can count the number of ones as well. That's not an issue at all. We'll go ahead with zeros. Okay, so for maintenance, element is 0. We'll do context this. Okay, now we are having a track of number of zeros that we are having in this string. Okay, now as I discussed earlier, there should be some minimum number of zeros, maximum number of zeros, as I discussed, right? If I keep on placing 010, 010, 010, 010, or if I keep on placing 101, 101, 101, 101, okay, this will keep a track of placing all 010s. Okay, this will again right? Minimum number of zeros possible 101. Maximum number of zeros 010. This will handle these two cases. Okay. Now as simple as how many iterations I need to consider. Okay, till k. Now uh, we need to consider this part, right? The current one, when we are at index 0, we need to consider it from 0 to 0 plus k, 0 plus k to 0 plus 2k. Okay, 0 to k, 0 to, I mean, k to 2k. Next, 2k to 3k. Next, 3k to 4k, and so on. So this thing we need to consider accordingly. However, it mandatorily need not to be 1 0 1 0 1 0 1. It can be 1 0 1 0 1. Here as well it can be 0 1 0 1 0. This way it can go up to from 0 to k, k to 2k. So this way you'll form something like a cluster. I mean, not a cluster, I would say, but I would say it's a chain. So that chain, what would be the length of that chain? It is as simple as we are having this index at this point, it will be as simple as n minus I minus 1 by k plus 1. So this is the chain length I am having at this point. Now, if I consider the minimum case, this will be chain length by 2. If I consider the maximum, it will be chain by 2 plus 1. That's it. And now at the end, this minimum should be less than or equal to the number of zeros that I'm having, which is being tracked by count variable, and this should be less than or equal to maximum. If this is the case, you can now obviously alter and you can find the string, okay, or else and no. That's it. Okay, we'll submit this. Okay, it gave us a wrong answer for some example. We'll just check that out. Okay, here this is n minus I minus 1. Okay, so as per the test, okay, sample has passed, right? We must have made a small mistake somewhere. Okay, this should be chain length plus 1 by 2, not chain by 2 plus 1. My bad. Okay, this should work. Okay, it worked.
Thanks for watching the video, guys. If you find this video helpful, please don't forget to like this video and consider subscribing to the 𝗏𝗍𝗃 YouTube channel. Your support helps us continue creating such a quality content along with enhancing your coding journey. Don't forget to check out other videos for more problem solving strategies and tips. And until next time, keep coding. Thank you all again and have a great day.